In this video, I tried to connect three different contributions to attempt to explain the working mechanism of cold fusion. The basic idea is that the low-energy nuclear reactions may happen thanks to the formation of binuclear atoms based on an idea of Gianfranco Cerofolini in 1991. Two independent studies, published more than 20 years apart, can confirm from an experimental point of view the validity of the hypothesis of the binuclear atom. All nuclei have a positive charge. In order for a nuclear reaction to occur, it is necessary that two nuclei approach each other at a sufficiently small distance below which the nuclear forces start to act. In order for this to happen, it is necessary to overcome the electrical repulsion generated between the two positively charged nuclei, which is highest just before the nuclear forces take effect. This is why the announcement by Fleischmann and Pons of having obtained nuclear fusion in a test tube under electrochemical conditions was immediately dismissed by hot fusion physicists. The main objection made to those who believe in cold fusion is that there is no compelling explanation for the mechanism to overcome the Coulomb barrier between the nuclei. In 1991, a few years after Fleischmann and Pons's cold fusion announcement, Gianfranco Cerofolini performed a series of experiments involving collisions of deuterated molecules against targets containing deuterium, and proposed a model that would explain the absence of the Coulomb barrier. Experiments with collisions of deuterated molecular projectiles against solid targets containing deuterium are used to give an experimental estimate to the threshold value of the energy of nuclear reactions, in other words, to estimate the magnitude of the Coulomb barrier. The resulting diagrams report the count of nuclear events as a function of the energy of the molecular projectile. There must therefore be a minimum energy carried by the projectile, for example a molecule of heavy water striking a deuterated solid, below which no nuclear events occur. We can see from the diagram that in practice there is no Coulomb barrier, or rather, that the barrier is so low that it is virtually non-existent, being at a value of just 30 electron volts. To explain this behavior, Cerofolini proposed that as a result of collisions, some metastable configurations may develop for a limited period of time in which two hydrogen or deuterium nuclei remain trapped at a small enough distance and for a long enough period of time to give rise to nuclear reactions. The structure of normal molecules is characterized by the motion of electrons around nuclei which are almost stationary or which perform small oscillations around their equilibrium positions. The binuclear atom, on the contrary, would be characterized by two nuclei which rotate as if they were the electrons of an ordinary molecule, surrounded in turn by the electrons. The peculiar characteristics of a binuclear atom compared to an ordinary molecule would be a high kinetic energy of the nuclei, because in a binuclear atom there would be no substantial difference between the motion of electrons and the motion of the nuclei. About 10 years later, Randall Mills showed a very peculiar experimental result working with plasmas of hydrogen and helium. The interesting result of the work consists of a series of spectroscopic peaks that are present only in plasma obtained from a mixture of helium and hydrogen, but that do not seem to belong to either hydrogen or helium, in that they are peaks that cannot be found in the spectrum of a plasma made of only hydrogen or only helium. It is possible to advance an explanation on the nature of these peaks. This is the formation of binuclear atoms of hydrogen which are catalyzed by the presence of helium. The interpretation of their nature is therefore the formation of a metastable species of hydrogen which is formed and stabilized by the presence of helium. The fact that we're dealing with a kind of hydrogen is also suggested by the fact that the spectral line of hydrogen shows a Doppler broadening that is reminiscent of a high kinetic energy of the hydrogen nuclei. This is therefore compatible with the formulation of a binuclear atom according to Cerofolini's idea, in which the binuclear atom would be characterized by a high kinetic energy of the nuclei. Another 10 years later, another experimental result on hydrogen confirms the existence of metastable states of the hydrogen molecule. It concerns the study of ultra-dense hydrogen by Professor Holmlid. Professor Holmlid is able to produce metastable aggregates of hydrogen in which the distance between the protons is extremely reduced, and this is estimated on the basis of the kinetic energy of fragmentation for these aggregates. This characteristic is therefore consistent with the high kinetic energy relative to the Doppler enlargement found by Mills. To explain these experimental results, Holmlid proposes for the ultra-dense hydrogen a structure made from a chain of mini hydrogen molecules. If we interpret the spectra of Mills and the ultra-dense hydrogen of Holmlid as the formation of binuclear hydrogen atoms, we are presented with a coherent picture of the underlying mechanism of nuclear reactions at low energy. We can therefore try to provide some clues of a possible formation mechanism for such a metastable state. By using Schrödinger's equation, it is not possible to find a solution that describes a binuclear atom. But when one studies the hydrogen molecule, some corrections are necessary to take into account some effects such as spin, relativistic corrections, as well as those due to quantum electrodynamics. The formula for one of these corrections, the spin-spin term in Breit-Pauli's Hamiltonian, has a very interesting functional form. In fact, the distance r of the nuclei appears in the denominator with a power to the cube. When the two protons approach each other, the spin-spin term would prevail on the Coulomb repulsion. Depending on the orientation of the spins of the two protons, this could be an attractive term. So this term could be responsible for the binuclear atom stabilization. Leaving the technical details of quantum mechanics aside, our recommendation is that we study the possibility of metastable states of the hydrogen molecule, which may be similar to the binuclear atom suggested by Cerofolini in 1991, and which may in turn explain the experimental results of Mills and Holmlid. So in conclusion, why can the formation of binuclear atoms provide a coherent framework to the underlying mechanism of cold fusion? Suppose that there exists a metastable state of the hydrogen molecule with the ultra-dense hydrogen characteristics outlined by Professor Holmlid. This state would have all the characteristics advocated by Gianfranco Cerofolini and would be responsible for the anomalous peaks in the hydrogen-helium mixtures highlighted by Mills. Holmlid uses a metal surface to catalyze the formation of ultra-dense hydrogen. There is a very important work that explains how, through the mechanism of image charges, a metal surface can have the effect of keeping two charges of the same sign at very close distances. This would explain the role of metal in the formation of binuclear atoms, thinking, for example, of palladium in the case of Fleischmann and Pons, or nickel in the case of Piantelli and Rossi-Focardi. So we can imagine that in the interaction of hydrogen or deuterium with a metal, in combination with an electric force or in a thermal gradient which provides an effect at the molecular level, has as its effect the production in situ of binuclear atoms on the surface or inside the metal matrix. In view of the production of heat in the Ecat by Andrea Rossi, Rossi-Focardi tried to publish an article, the Rossi-Focardi paper, that has then given motivation to Rossi to create the blog Journal of Nuclear Physics. Now I want to show that the hypothesis of binuclear atom solves the discrepancy at the base of that publication and the reason why it was not accepted by peer-reviewed journals. Rossi-Focardi estimated the possibility of nuclear reactions starting from the energy of the hydrogen nuclei, the protons, within nickel. We know that the temperature is 1500 degrees by the equation E equals kT, which determines that the average energy of protons is 0.13 electron volts. Using this value in the Gamow formula to calculate the value of probability of a nuclear reaction between the hydrogen nucleus and nickel, you get a value too low, which absolutely does not justify the production of heat in the Ecat as an effect of nuclear reactions. But if we now think about the formation inside of Rossi's Ecat of binuclear atoms, with the features highlighted by Professor Holmlid, we have to consider the kinetic energy for the protons of the order of 1000 electron volts and no longer just 0.13 electron volts. Do you know what temperature corresponds to an energy of 1000 electron volts for the protons? It would be like having hydrogen at 11 million degrees inside the Ecat. So in conclusion, if the existence of binuclear atoms is confirmed, it would represent a revolution in physics and chemistry and would allow to explain the mechanism by which nuclear reactions occur at low energy.